You'd said that there was evidence to indicate that the prints were made during the flood,
Yes.
and there's the caryopine out on the front that's crushed oval.
Yes.
Was that crushed? Was that the same time frame as the prints? And do we have any evidence to support that?
All right. All right. Good question. 18 feet below you, 18 feet below this museum, we have anchored the piers in bedrock. That bedrock is a part of the system of the Cretaceous layering adjacent to the Austin Chalk. It's not chalky, it's just whitish limestone. That system was first identified in the technical literature near Austin, Texas. That's the reason it's called Austin Chalk. Derek Egger, world-class geophysicist, major evolutionist, deceased, came here to examine this. He published the nature of the stratigraphic record. So what I'm saying, I'm not just making up. He published the sedimentary limestone in this system of layering. Now, how do you get sedimentary limestone or sedimentary rock? Whether it's limestone, sandstone, whatever, sedimentary rock. You have to have mud that has the right chemicals in it. You have to have mud mixed up and moved about in water, and then the water has to drain off. So the formula, CaCO2, but we're not talking about that formula, we're talking about the general makeup. You have to have the right chemistry in mud. You have to have a lot of water. It has to be mixed up, and the water has to be drained off. With that, Derek Egger published in the nature of the stratigraphic record that beginning in central Texas near Austin, this series of sedimentary layers, piled one on top of the other, whole series, one after another, extend 1,600 miles to the eastern seaboard. They drop off. They pick up again at the White Cliffs of Dover. The same limestone, 18 feet below us here, extends throughout Europe, throughout Scandinavia, throughout Russia, throughout China, throughout Saudi Arabia, throughout the Middle East and Israel, throughout Africa. This same layer is in Africa. Back to Texas. It extends north throughout the continental United States, extends south throughout Mexico, Central America, and all of South America, the same layer. It extends west, is broken up in the Rockies, picks up, goes all the way to Los Angeles, it drops off, picks up again in Australia. Other than the islands that are volcanic in nature, the entire globe is enveloped with a system of sedimentary rocks in place. The only way you can get that much intact sedimentary rock is to have a worldwide flood. There was a worldwide flood. Ancient documents are very clear, but modern scholarship has to deny it, because if there was a worldwide flood, it explains the whole thing in recent times. And it does explain the whole thing. But Tim was asking about a special condition. Please take a look at this fossil, this limb, this tree fossil out on the edge of the platform at the museum. It is an Araucaria pine. Araucaria pines grow round. Now, that's a big one, but it's compressed into an oval. While it was still pliable, it was compressed, and the rings are compressed into an oval if you look at the end of it. That was found at our dinosaur excavation site in Colorado. The landowners gave it to the museum. Another friend paid to have that transported all the way from northwestern Colorado to our dinosaur excavation site, all the way to Glen Rose. Now here's the thing. while that Araucaria pine was intact, there are 20 layers above it. These layers extend through 11 states and into Canada. So we're not talking about a local flood. We're not talking about a single episode. We're talking about layer after layer after layer coming back, coming back, coming back, laying a system down that is intercontinental, and it connects directly with the Cretaceous layers under our museum at a distance. They're joined with polystrate fossils. Tim, while that thing was still pliable, those layers formed, compressing it. In other words, there was a worldwide flood. That's the whole point.